We will now find the derivative of this expression. So we have a derivative of sine x raised to the power of cos x squared plus x power pi plus pi power x plus log of 3 minus x to the base 3. So basically we have to find the derivative of an expression which has about four terms. So here we can apply the sum rule of derivatives, and so therefore we can write down this as a derivative of each of the terms like this, that is d by dx of sine x raised to the power of cos of x squared. This is one derivative, plus the second derivative as d by dx of x raised to the power of 5, plus the derivative of the third term, that is d by dx of pi raised to the power of x, plus finally the derivative of the fourth term, that is d by dx of log of 3 minus x to the base 3. So it basically involves finding each of the derivatives and them adding them up together. So here I'm going to call the derivative of each expressions as denoted by some letter. So let's say the derivative of this first expression is d1, and the derivative of the second expression is d2, and third is d3. The fourth, we let's say this as d4. So basically we are going to find derivatives like d1, d2, d3 and d4 separately one by one and add them up together, which gives the result of the derivative of the given expression. We will now find the derivative of the first expression, that is sine x raised to the power of cos of x squared. So I'm going to consider this expression as y, that is y equals sine x raised to the power of cos of x squared. And notice that we can apply this formula, that is, if we have a function in the form of y equals f of x raised to the power of g of x, then its derivative is given by y prime equals f of x raised to the power of g of x multiplied with, we have a big square bracket, g of x over f of x times of f prime of x plus g prime of x times of natural logarithm of f of x and the square bracket closed. So this is basically the derivative of any expression which is in the form of f of x raised to the power of g of x. And clearly we can see that even our function y equals sine x to the power of cos of x squared. It's in the form of f of x, where we can consider the sine x as f of x and this cos of x squared as g of x. So therefore we can utilize this formula. In fact, one can easily derive this formula by taking natural logarithm to this equation on both sides and then finding its derivative. So we can use this formula now. So I'm going to use this formula, that is y prime. In fact, our y prime is equivalent to d1 because we are finding the derivative of the first expression. So I'm going to replace into this formula, that is f of x raised to the power of g of x. So as I consider f of x equal to sin x and g of x equal cos x squared, I just put this as sin x raised to the power of g of x, which is cos of x squared multiplied with the square bracket g of x over f of x. So our g of x is cos of x squared. So I write down this as cos of x squared over f of x is sin x, and then multiplied with the derivative of f of x. This is our f of x, that is sin x, and derivative is cos x. So we write down cos x here. We then have this plus g prime of x. So I put plus, and then the derivative of g of x, which is g prime of x. So let's find the derivative of g of x here. We have g of x equals cos of x squared. We have to find its derivative. So here we have to apply the chain rule because it's a composition of function cos x as well as the x squared. So when we find the derivative of cos function, we get negative sin x. So I write this as negative sine of, since it is x squared, I put sine of x squared. And then we have to find the derivative of x squared by applying the chain rule. So when you do that, derivative of x squared using the power rule is 2x. So basically this is the derivative of g of x. That is, we can put this negative 2x in front and then write down this as sine of x squared. So I substitute here. Therefore, g prime of x is negative 2x. In fact, I can remove this plus and put this as negative 2x times of sine of x squared. And then let's go back to the formula. We have natural logarithm of f of x. So we put this as multiplied with natural logarithm of our f of x is sine x. So it is basically natural logarithm of sine of x. And we then close the square bracket. So basically this is the first derivative of the function sine x raised to the power of cos of x squared. That is, this is our expression d1. We now find the d2, which is the derivative of the expression x power 5. So this is d2 is d by dx of x raised to the power of 5. Here we can apply the power rule of x power n. That is, derivative of x raised to the power of n is n times of x power n minus 1. So we can apply this rule. So therefore, this d2 equals, we put the pi in front and x raised to the power of pi minus 1. So this is the d2. We got the expression for d2, which is pi x power pi minus 1. Let's find d3. So basically d3 is the derivative of pi raised to the power of x. So for this, we will utilize this formula. That is, if we have an expression a raised to the power of x, its derivative is given by y prime equals natural logarithm of a times of a raised to the power of x. So in our case, we see that a equals pi. So we can substitute into this formula. So therefore, we get d3 equals natural logarithm of a, that is natural logarithm of pi times of a raised to the power of x, that is pi raised to the power of x. So this is the derivative of the expression pi raised to the power of x. Let's find d4, which is the derivative of the expression log of 3 minus x to the base 3. So d4 is derivative of this expression log of 3 minus x to the base 3. First, before I find the derivative, I'm going to rewrite this logarithm using the change of base rule, which I have given over here. That is, if we have log a to the b, this could be written as natural logarithm of a to the natural logarithm of b. So therefore, this will become t by dx of natural logarithm of 3 minus x is the a over natural logarithm of b is 3 here. So it becomes a natural logarithm of b. Now we can easily find the derivative. Since this natural logarithm of 3 is basically a constant, we can apply the constant multiple rule and then factor it out of the derivative. So therefore this becomes 1 over natural logarithm of 3 and then the derivative of natural logarithm of 3 minus x. So we now find the derivative of natural logarithm of 3 minus x. So I write down this as natural 1 over natural logarithm of 3. Derivative of natural logarithm of f of x is basically 1 over f of x multiplied with f prime of x. So this is the derivative of natural logarithm of f of x. So therefore we apply this formula. So this becomes 1 over f of x, which is 3 minus x. And then using the chain rule, we find the derivative of this expression 3 minus x. Derivative of this expression is basically negative 1. Since 3 is a constant, it becomes 0. So we get this expression. This can be further simplified. So therefore, this becomes, we have negative 1 in the numerator and natural logarithm of 3 in the denominator. So when we combine both, we get negative 1 by natural logarithm of 3 multiplied with 3 minus x. So basically, this is D4. So now we have found all the expressions D1, D2, D3, and D4. That is the derivative of the four expressions. We just have to add them together to find the derivative of the given expression. So this is basically equivalent to D1 plus D2 plus D3 plus D4. So here I have added all the four expressions, that is D1, D2, D3, and D4. So this expression, which is a little bit of lengthy, is basically the derivative of the given expression.